Hello guys, welcome to my YouTube channel. So today topic is so now non-conventional energy resource. So the subject code is 18ME651. So now topic is solar photovoltaic system. So what is photovoltaic cell? That is PV cell, or it is short form called as PV cell. So it is a device that converts solar energy into electric current using photoelectric effect. So the solar energy we get from the sun, it is converted into electric current using the photoelectric effect. About photoelectric effect, we will soon come to know about that. So photovoltaic power generation employs solar panels composed of number of cells, so number of solar cells containing photovoltaic material. Photovoltaics are made up of semiconductors and it converts solar radiation into direct current electricity. The solar cells are made up of semiconductor materials such as silicon that absorbs photons from the sun and releases electrons, generating a flow of electricity. A solar photovoltaic system can be installed on the rooftops of buildings as well as in open fields. So we can in many places the solar PV systems are installed on the rooftops of buildings, like in your houses or colleges and in open field also. So the types of solar panels, there are mainly three types: monocrystalline, polycrystalline and the thin film. So according to this, the monocrystallines are one of the most expensive ones, and the polycrystallines are average one, and the thin films are the cheapest. So the first solar cell to generate electricity. The first solar cell to generate electricity was in 1883 by Charles Fritts in US. Pressed now press a thin film of selenium against a brass metal plate, then laid an even thinner layer of gold on top. The gold layer was so thin that the sunlight could penetrate through it. Exposing the gold to sunlight resulted in electricity generation. So a thin film selenium was placed, and on that the gold layer was also placed so that the sunlight easily penetrated through it. This is how the electricity generation happened. Werner Siemens, who confirmed Fritts' experiment, commented. He commented that, in conclusion, I would say that however the scientific importance of this discovery may be, its practical value will be no less obvious when we reflect that the supply of solar energy is both without limit and without cost, that it will continue to pour down upon us for countless ages after all the coal deposits on the earth have been exhausted and forgotten. So the most important one here it is, the working principle of photovoltaic cell. As you can see in the diagram, there will be a source of incoming light either it may be from the sunlight or any source of light. An anti-reflective coating is on that. The conducting metal strip is placed here, and there are two types of semiconductors here, from N-type and the P-type. The electricity circuit has been shown here, plus for the holes and the minus for electrons. So here, photovoltaic cell is made up of semiconductors, metals like silicon. One layer has N-type silicon and another layer has P-type silicon. An interface between N-type and P-type called as PN junction. So here it will be the PN junction between N-type semiconductor and P-type semiconductors. In PN junction, semiconductor material electrons from N side tend to move towards P side rapidly, combined with large number of hole concentration. So electrons from N side move towards P side. Electrons moves from N side to P side. Similarly, holes from P side tend to move towards N side. So holes move from P side to N side, combined with large number of electron concentration. This charge distribution across this junction gives rise to electrical field. So here it will be the electrical generation will occur. When a PN junction semiconductor material is exposed to the sunlight, some of the solar photons will have a tendency to dislodge free electrons from its fixed position in the material. So now next, ejected free electrons tend to move towards the p side, and this flow negatively charged electrons constitute an electric current. So the free electrons tend to move towards the p side. This will generate a free negative flow of negatively charged electrons that will constitute the electric current. So the advantages, here are some advantages. Very little research money has been invested in the development of solar cells, so it is a cost efficient, effective. It gives long duration period. Operating costs are extremely low compared to existing power technologies. Now the many power technologies are there, but it is one of the cheapest one. So applications of solar PV systems, there are 5 are listed here. So let's see. First one, residential. Solar PV system can be installed on the rooftops of homes, generate electricity from homes. From the homes usage we can generate the electricity. This can help to reduce the homeowners electricity bills and their carbon footprint. Now the next is commercial. The many business are now installing solar PV system on their rooftops to generate electricity for their operations. This can be help business save money on their energy bills as well as improve their sustainability credentials. So the third one, industrial. Solar PV system can be used in industrial applications to power machinery and other equipment. And the fourth one is remote areas. Solar PV systems can be used to remote areas where there is no access to the grid. These systems can be used to power homes, schools, clinics, and other facilities. So now the fifth one is agriculture, the most important one. Now everyone know how important is agriculture one, and we have to develop more in the agriculture field. Solar PV system can be used in agriculture to power irrigation systems, lighting, and other equipments. Transportation. Solar PV system can be used to power electric vehicles, charging stations. So the finally we come to a conclusion here. Overall, solar PV systems are a clean, renewable source of energy that can help reduce the carbon emission dependence on fossil fuels. As the technology continues to improve and become more affordable, we can expect to see even more widespread adoption of solar PV systems in coming years. So we can accept that many widespread adoption of solar PV system can in coming years. As so, thank you guys. Hope you like. Thank you. I conclude here.